Hello, I am David W. Parker. This is Programming Today I Learned 3D Math Series, episode 45. We're looking at matrix code part 4. We're looking at setRotateX, Y, Z, rotateX, Y, and Z, and then actually rotate. Last time it was just setRotate. And we're going to see how we can use these comparably. So setRotateX is very, very simple. setRotateY, similarly simple, and rotateZ, also simple. All three of these are in episode 11 if you're wondering how this math is derived. It's fairly simple. So what we're going to do, let's go ahead and look at the code here. So we can see we're going to set the identity matrix and then rotate it and then print it out. If you were an astute watcher of the previous episode, we did the same kind of thing with rotation, but we used an array before. But you'll note that we just returned the rotation matrix based off the identity. So we'll be fixing that in this episode, but you can see how it's done here for the setRotateX versus doing the rotation setRotate. So you could see here is the rotateX at the above, and then here's the setRotate with the same results. So this is equivalent to this, it's just done in a different way. So this kind of like saves you a little bit, so you could actually just do new mat for .identity. You can actually even just go all the way down and do something like that if you wanted to. We do the same thing for rotateY and compare how it's similar to creating from a rotation with the vector of 0, 1, 0 and 0, 0, 1 for the z vector. So those are all fairly self-explanatory. Now let's talk about the rotation and how we use these. So we have a couple new things here. We can actually use the setRotate, and what the setRotate does, this rotation matrix, is once we use it, we can multiply it by a matrix that has some values in it. So for example, r's are up here, and that is the same thing as the rotateX method that we will have here. So this method is just kind of shorthand, and you can see all these times c's and plus times s's and minus times s. And that's actually, when you look at it, you'll see c plus times s and then c times minus s. And that's where those values come from for the pluses and the minus. So that's why you can actually just go ahead and use the set and get the rotation matrix and multiply it, or you can just call the singular function rotateX all at once. So it's just kind of shorthand notation, and it makes things a little bit simpler. We're doing the same thing with rotateY as well as rotateZ. So you can scroll down and see these values here and these values here are derived from the same formulas that we derived in episode 11 to determine the rotation matrices. Finally, and as we scroll down, we can see we have rotation here, and this is on an arbitrary axis. In our example here, we're just doing it around the x-axis though, and we can do the whole longer version, which we're doing, like I said, the identity, and then we're going to go ahead and set the rotation and then multiply it by this array. Or we can go ahead and just do a shorthand version called rotate. In this particular example, what I've done is copied and pasted all of the set rotation code from above. We can actually probably shorthand it and maybe call the other function to make it a little bit easier. Up through till this point right here where we're setting the rotation elements, and instead of setting them directly on the that object, we're going to go ahead and create them as all new elements here, and then copy the existing ones and then perform the matrix multiplication ourselves manually, which is, like I said, the same thing as doing this. So a lot of easy, nice stuff though, and compact shorthand versions to do rotations using setRotate versus rotate. And well, that's it for this episode. If you like what you saw, go ahead and subscribe and share this on social media if you will. Give me a like, that'll always help. Go to ProgrammingTIL.com and sign up for a newsletter. Thanks. Have a great one.